channel Gain of Knowledge. This is the part 2 of the same chapter, electric current and its effects. Let's begin. Now I had explained about electric bulb detailed in the part 1 video. So today I'm going to explain you about the electric fuse. Although the heating effect of electricity is very useful for making different heating devices, it also has its shortcomings. If a large electric current flows through the circuit, after a certain time, the heat generated from the electric current becomes so high that it can melt the conducting wire and damage the insulating wire coating. The wire may even catch fire. It can also cause permanent damage to the parts and insulation in the appliances due to overheating. To prevent this, a safety device called an electric fuse is used. It is interesting to know that the working of an electric fuse is based on the heating effect of the electric current. An electric fuse consists of a thin wire with a low melting point like copper, silver, or aluminium, or some alloys of tin and lead. The fuse wire can withstand a certain amount of current. If the electric current in the circuit exceeds this limit, the heat generated causes the fuse wire to melt and break off. Thus, the circuit is broken and the flow of current stops. This in turn prevents further damage to the electric circuit due to overheating and protects the electrical appliances from permanent damage. Now you can see here, I'll show it. As you can see here, this has one thin line of wire. This is only called as the metal wire, which has a low melting point. This thin wire. As the fuse melts and breaks off during its operation, it cannot be used again and needs to be replaced. Large amount of current can flow through a circuit due to two reasons. One is short circuit and second is overloading. A short circuit occurs when two wires carrying current has come directly in contact with each other due to the loss of insulation of wires, mixed up wiring and loose connections can also lead to the short circuit. I guess you guys, a lot of you guys can see this short circuits in the electric compass which are present near our homes or far from our homes. Actually, if you take a deep look in them, the wires are not insulated in a lot of area, and they contain a lot of volt in them. That is 230 volt. And note, please don't go and touch it. There is chance that you can die, and it contains a high volt. And see, these two wires are uncoated, so they caused the short circuit. This can damage the whole system of the whichever the transmitter or the transformer can be wholly full means it is wholly can be it is gone or it will be wasted due to the short circuit, and it stops working at that time. Now overloading occurs when too many devices are connected to the same power point. For example, if the fridge, oven, mixer, toaster, etc. are all connected to a single plug point in a household circuit. Nowadays, we can connect some other safety devices like a miniature circuit breaker (MCB) to the circuit, in addition to or as an alternative to the fuse. Now let's learn about MCB. Now see, this is a miniature circuit board. I know that everyone has MCB in their house, maybe in their power plugs, the main power points there. Now, a miniature circuit breaker MCB is a switch which automatically turns off in the cases of overloading of short circuits and protects the circuit. An MCB is a better alternative to a fuse since it does not require any replacement. As you can know that in the fuse, once if it is gone, we have to replace the whole fuse. But in MCB, it's not required. We just have to pull this lever down and it starts working again. Unlike a fuse on MCB can be easily reset just by lifting up the switch after the fault is fixed, as I told you. Besides producing heat in a medium, a current passing through shows other effects like a magnetic effects of electric current. When a current is passed through a the wire starts behaving like a magnet. This is called a magnetic effect of electric current. Electromagnet. Electromagnet. When a wire is wrapped around a soft iron piece called a core and an electric current is passed through it, then the iron piece behaves like a magnet. This kind of magnet is known as an electromagnet. And an electromagnet is also known as a temporary magnet as it only behaves as a magnet in the presence of a current. On removal of the current, it loses its magnetism. Now let's learn about the strength of an electromagnet. Greatly depends on on some certain factors. First, the number of coils of the wire. With increase in the number of coils, the strength of the electromagnet increases. As you can see here, there are a lot of wire wrapped along with the core. See here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 wire rounds wrapped along with the core. Second is amount of current passed. Increase in the strength of the current also leads to an increase in the strength of the electromagnet. Third, winding the wire around a magnetic material also increases the strength of the electromagnet. The most common type of electromagnet used is a solenoid. As you can see here, this is solenoid. This is a cylindrical electromagnet which is prepared by winding a long insulated wire around a soft iron core. Electric bell. Magnetic bell. An electric bell is made up of using an electromagnet which is connected to a source of current through a switch. It works in the principle of the magnetic effect of electric current and is a direct application of an electromagnet. An electric bell is composed of a horseshoe type of electromagnet, as you can see here, an armature, as you can see here, a contact adjusting screw, as you can see here, a soft iron strip, and a hammer and a gong. This is a hammer and this is a gong. The armature contains a soft iron rod. One end of an iron rod presses against the top of the contact adjusting screw, and the other end of the iron rod is attached to the spring metal which is fixed to a rigid support. There are some steps involved in the ringing of an electric bell. 1. When the switch is closed, the circuit is complete and the current flows in the circuit to the electromagnet. 2. The electromagnet attracts the soft iron strip. Since the hammer is attached to the strip, it hits the gong and produces sound. 3. On getting attracted to a magnet, the soft iron strip loses contact with the screw, because of which the circuit breaks. The electromagnet loses its magnetism and the soft iron strip goes back to its initial position and touches the screw. This completes the circuit again and the current flows once again in the closed circuit. 4. As long as the switch is closed, all three steps are repeated and we hear the ringing of the bell. This is the end of the chapter Electric Current and its Effects. Stay tuned. Let's meet with the next chapter. Till then, bye bye.